During World War II, Germany, Japan, and the other Axis powers suffered huge casualties and major losses in capital. They lost the war, and with it went their economies, which were decimated by bombings and invasion. Nevertheless, after the war, the growth rates in the countries that lost the war were significantly higher than those in the countries that won it. France, where the economic devastation was greatest among the Allies, was the fastest growing. But the United States, which saw very little combat within its borders, stagnated for the 10 years following the war. But Austria, Germany, Italy, and Japan all had growth rates which were higher than the average for the world. These economies doubled in size after the war or more. So what gives? To find an answer to the mystery, we need an economic model. An economic model is a simplified description of reality designed to yield hypotheses about economic behavior that can be tested. Often, these economic models are expressed as mathematical equations. For example, I might have a model to describe how many units of a product we will sell depending on the price we charge for it. Perhaps my model is that the quantity sold, Q, is equal to 100 minus the price charged, represented by P. We can plot this model on a graph, with each of the two variables represented by one of the axes on the graph. Here I have price on the vertical axis and quantity on the horizontal one. My model translates to this line on the graph. At every point on this line, the equation is true. So if the price were $90 each, my model predicts that we would sell 10 units. You just plug in 90 for P, the price, and solve the equation for Q, the quantity. Likewise, if I plug in $10 for P, the model says we will sell 90 units. The value of a model is that it makes predictions about the world, and we can look and see how things actually go and test whether or not the predictions were accurate. So I might randomly change the price every day and see how many we sell and collect that data. I could then plot the price and quantity sold each day and see if it's close to the predictions. This data started off looking pretty good, but then veered away. I might need to modify my model so that the slope of the line isn't so steep. We have seen quite a few economic models already, like the production possibilities curve, supply and demand, and the Malthusian model of the economy. Each of these models make predictions about the world, which we can test. But now we need one for economic growth. In the 1950s, the economist Robert Solow developed such a model. He wanted to explain the causes of economic growth based on certain key variables that we presumably have some control over. The goal of Solow's model was to translate these variables into a prediction about GDP. Solow's model made some surprising predictions, at least for their time, such as the one about the war-torn countries growing faster than those relatively untouched by war. For this work, Solow was awarded the Nobel Prize in Economics in 1987. To begin, Solow needed to think about the economy's production function. At a basic level, the economy transforms resources into goods and services. But that doesn't just happen automatically. It takes people and tools to make that happen, or as we call them, capital and labor. These are the basic inputs for the economy. Using capital, which we represent with the letter K, and labor, which we represent with the letter L, we are able to transform resources into goods and services. The total amount of goods and services produced by this process is our real GDP, aka the economy's output, which we represent with the letter Y. This is a really simple description of the economy, but this is what models do. They simplify the world into something we can think clearly about. How do we make smartphone apps? Well, we use computer programmers and computers, labor and capital. How do we make bread? Using mills and mixers and the talents of a baker, capital and labor. Pretty much everything in the economy boils down to those two broad categories. Of course, to really be able to use our model and see what it says, we need to express it mathematically. Our real GDP, Y, will be determined by some mathematical function, which takes capital, K, and labor, L, as the inputs. That's what this italicized F with parentheses means. It's a placeholder for some yet undefined mathematical equation. So what equation do we use? It can be anything. Maybe it's y is equal to k plus l, or y is equal to k times l, or y is equal to k raised to the 1/2 power times l raised to the 1/2 power. Heck, it could be as crazy as we want, like 5 times k squared plus 0.8 times the quantity k minus l raised to the 1/2 power plus l cubed. Deciding between these is going to be a matter of observation. We want a production function which gives similar results as the real economy. But first, we need to build on our theory of production.